Hi everyone and welcome back to Maths and Physics with Mr. Simons. Right, today's lesson, grade 12, vertical projectile motion. Right, now we're looking at the third variation of the 7 variations that have been tested previously. This is from the November 2015 exam, and here is when an object is projected vertically upwards. Right, then we also bring in as a question when a second object is either dropped or thrown down. And we're going to test your knowledge of simultaneous equations to solve whatever we're testing between the two. How far have the two moved together, or at what time would the two meet each other in the middle, etc. But generally the two objects will be moving towards each other. Right, so ball A is projected vertically upwards at a velocity of 16 meters per second from the ground. Ignore the effects of air resistance, use the ground as zero reference. Right, so we're starting from the ground and we come back to the ground. Calculate the time taken by ball A to return to the ground, 4 marks. 3.2, sketch a velocity time graph for ball A. Show the following on the graph: initial velocity of ball A, time taken to reach the highest point of the motion, and the time taken to return to the ground. So this is the first part of November 2015. The second part I might typed as a separate question. Alright, so 3.1, calculate the time taken by ball A to return to the ground for 4 marks. So ball A is projected vertically upwards at a velocity of 16 meters per second, as you can see then. Now we have final velocity, or we have our 4 equations that's given to us. We need to know how to choose the correct one. Right, so we're taking down as positive. So moving this way is positive. So there A, I throw it upwards, it's going in the opposite direction, therefore negative 16 meters per second. While moving up, gravity is pulling it back down, slowing it down, so gravity is 9.8 meters per second squared. Right? If I throw something at 16 meters per second and the only thing slowing it down is gravity, and when it comes back down the only thing that's speeding it up is gravity, then yeah, when it comes back to the ground, the final velocity must be the same as the initial velocity, but in this case it's positive 16 meters per second and initial is negative 16 because the two are moving in opposite directions. We want the change in time. Alright, so we look at which equation. I'm just showing you how we go about selecting our equation. So I have initial velocity given. Alright, so they have initial velocity, initial velocity, initial velocity, initial velocity. So all 4 equations have initial velocity. Gravity, which is A in the equation, or gravitational acceleration, they have A, they have A, they have A, no A there, so equation 4 falls away. Final velocity, I have it in equation 1, I have equation 2, final velocity, right? But no final velocity in number 3, so number 3 and 4 now both have fallen away. Right, now for the last part I want time, so equation 1 has no time, but equation 2 has time, therefore I'm using VF equal VI plus a change in t, because all 4 items appear in equation 2. So final velocity positive 16, initial velocity negative 16, a 9.8, and t there simply stays t. That is what I'm trying to solve. Take negative 16 over 16 plus 16 would give me 32. 32 divided by whatever is in front of t, which in this case is 9.8, and my time then becomes 3.27 seconds. So that's how long it takes this ball to go up, reach the highest point where it's 0, and then turn back, coming to the ground. Alright. 3.2, sketch a velocity time graph for ball A. Right. So show the following on the graph: initial velocity on ball A, time taken to reach the highest point of motion, C, time taken to return to the ground, 3 marks. So you remember we took down as positive. So initial velocity, the graph starts from negative 16, and final velocity, it goes to positive 16, right? Now it's moving up, so it's going to reach the highest point and then turn. So it's slowing down from negative 16. It goes till it reaches 0, and then once it reaches 0, it speeds up again as it comes back to the ground, right? All in all, the time we worked out was 3,26 or 3,27, depending on how you rounded off. So the time to get the highest point would be exactly half of this time. So if I half the 3,27 divided by 2, time taken there would be 1,63. So 1 mark for correct shape, or correct shape for extending beyond 1,63, right? Understanding that. Initial velocity being minus 16, so graph starting at the right side. So you can't start by positive 16 and down because we took down as positive, right? So it went from minus 16 to 0, and then from 0 to positive 16, right? And then time to reach maximum height, the 1,63, that is my third mark, all right? So this is the easier part. Now we're coming to the more complex simultaneous equation. So you have to follow very carefully now. 1 second after pole A is projected upwards, the second pole B is thrown vertically downwards. So this ball travels for 1 second before this one is thrown down, according to what it's stated there. That ball is thrown down at a velocity of 9 meters per second from a balcony 30 meters above the ground. So from there to there is 30 meters. Refer to the diagram below. Calculate how high above the ground ball A will be at the instant the two balls pass each other. So at that instant where this one's coming down and that one going up, at what time or how high is it? So I need to know at what time they meet each other to work out how high they would be. Alright? So we need to know when this ball is traveling down and A is traveling up. Number one, there where they meet together, they would have collectively traveled 30 meters. Alright, so I'm going to use that as part of my solution. At the same time, I also need to understand that there, for them to meet and to treat this as a simultaneous equation, the time must be the same. So if I make the time for A t, then the time for B would be t minus 1, meaning I want the two to start at the same time to ensure that they meet at the same time and have moved the same distance. So the t minus 1 comes because ball B was thrown 1 second after ball A. Alright, so let's look at the problem. So calculate how high above the ground ball A will be at the instant the two balls pass each other. So there again, there's my 4 equations that I have to correctly choose from. So if we look at ball A, initial velocity, negative 16, it's going up because we take down as positive. Gravity, 9,8 seconds, and we will take the time as t. Look at ball B was chucked down or thrown down. So initial velocity, 9 meters per second squared. Gravity 9,8 meters per second, but because it's thrown 1 second later, we're going to subtract that 1 second so that they leave at the same time. So therefore change in time equal t minus 1. Alright, so if you look, I have initial velocity, gravity and time. I want distance, so how high? So for distance x, I have initial velocity and I have the gravity. Right, so there, change in x or change in y for a, whichever way you write it, equal initial velocity times the change in t plus a half a change in t squared. Same for b. So initial velocity, substitute in negative 16t plus half. Gravity is 9,8 t squared. No? Half times 9,8 gives me 4,9. So my equation for the distance traveled by A would be negative 16t plus 4,9 t squared. For ball B, my initial velocity, because it's moving down, is 9,8. Gravity, not 9,8, initial velocity 9 meters per second. Gravity, 9,8 meters per second squared. So there, initial 9, change in time, t minus 1. Half 9,8 t squared t minus 1 squared. So I say 9 times t gives me 9t. 9 times minus 1 gives me negative 9. Half times 9,8 gives me 4,9. And this is where the problem comes in. We catch you out to this in maths, and we're going to catch you out in physics as well as in chemistry, where you can retest it under the KC, etc. Right? So what I mean, you forget the middle term. So t times t, t squared. T times -1 gives me negative t, times 2 gives me negative 2t for the middle term. -1 times -1 gives me positive 1. So from here, now I have 4,9t squared. If I multiply out, 90 minus 4,9 times -2 gives me negative 9,8t. So negative 9,8t plus 90 would give me negative 0,8t. And then I have minus 9 plus 4,9, which gives me negative 4,1. So 1 there for creating the equation of A, 1 for the correct formula, correct substitution, and correct second formula. All right. So we have the distance for A, we have a formula, distance for B. So I said after these two travel and they meet each other, collectively they would have traveled 30 meters. Therefore I can say distance of X plus distance of B must equal 30 meters. However, take note, A is moving up, so therefore negative, B is moving down, therefore positive. So negative change in the distance of A plus the change in distance of B equal 30. So that becomes negative, in brackets, negative 16t plus 49t squared plus 49t squared minus 0,8t minus 4,1 equal 30. Right, that gives me 16t. Right, we multiply out negative 49t squared plus 49, squared minus 0,8t, and if I take minus 4,1 over, it becomes plus 4,1. Minus 4,9 plus 4,9, those two cancel like terms. 16t minus 0,8t gives me 15,2t. 34 divided by 15,2 would give me 2,24 seconds. Right, substitute back in. Remember we want for pole A, so distance traveled by pole A, there t becomes 2,24. T squared becomes 2,24 squared. If I multiply them out, I get negative 11,25 meters. So the height that pole A traveled before it meets pole B is from here to there, 11,25 meters. Right, so I hope you follow there. 1 mark for time and 1 for basically getting correct answer. Should be more than 6 marks, but yeah, take note, if we make it more, that means if you make an error, you're losing more marks. Right? I hope you understand. You can pause it, look at it, work through it piece by piece, read to it, pause, whoever explaining, make your own notes. Alright? But very important that you understand how to work with simultaneous equations. So this is one of those surprise questions. Also ensure you get used to all the different variations. God bless. Bye.